In this video, I'm going to be showing you how I was able to install a brushless motor kit and double the speed of this Tesla Cyberquad. Dude, this is crazy. Oh, so it's not even assembled, man. This is great. So the first thing is really just to hook this thing up on a charger. Oh, you got back issue, right? You alright with your back? Yeah, I'll help you, man. I'll get this together. I'll get this thing running. You can submit your controller back. So Radio Flyer put out a recall last year, I think October 2022, to deactivate all of these Tesla Cyberquads because there were adult riders riding these things and getting hurt. So they were giving people who bought them full refund if you just send the controller back.
Take a picture of this bum laying down on the job. I might send it to Joey and say, hey,
Don't do it.
What's this guy doing? He's sleeping on the job.
Don't do it, man. Production manager about to get my ass fired for working on a Tesla during work. Even though we work on Teslas here all the time. So this thing runs off of a 36-volt lithium battery pack. It's pretty slick. This is what the charger looks like. It just slips right into the back. Assembly-wise, is very similar to my Razor projects. Like, this is just a brushed motor, very similar to like a MY1020. And then this is just a mountain bike rear shock. Slide the battery in, see if it turns on. Damn.
We gotta see what it does before we do
modify it, yeah. All right, one. That's it. I'm not really sure what those two are. I think one is speed. I don't know.
Oh wow, yeah, it's got front and back lights. Come on.
Yeah.
Wow, that's maybe why. It doesn't have or it doesn't have like a safety.
It's got reverse. That's pretty cool. All right, where am I riding this, Anton? Can't hit a Rolls Royce. Oh, there's a faster speed. Oh, there it is. That is not too bad.
Maybe that's why they don't want you to have it, right?
Yeah, now it feels like it wants to tip over a little.
Fuck it, whatever you think.
Now that I have a general baseline of the performance of this thing, it's time to take it apart so we can take out the controller. He can send it out for the refund process and then get a better look at the electronics, see how we can upgrade it.
You know, chores, you know, you gotta do in a week to put in these people's cars. You say, you're already nuts.
Is it?
They started it like a decade ago. The controller cost after they got the Maserati went back twice. Every like darker color carbon buck, he did that thing twice yesterday. He did the initial. When I got the car, when he got the job, they knew that he was in the military, and they 2 months to 4 months, and I kept it.
Yep.
He's got
So now I just gotta unplug all the harness connectors. Yeah, they make it seem complicated, but it's not as complicated as
but
you
they
think.
want where the battery goes. That's what they want.
Yeah, so this is just the...
Why is this shit look familiar?
This,
so this
man.
is the only pain right there.
Yeah, this is the only pain because like this is not a standard plug you can just buy. But that's the power source. That's how it gets power from the battery. It slips
And
on
is
this
that just
way.
like that's already heat shrunk on and everything, or that pulls off?
That's already heat shrunk on. Now the whole purpose of this project is to get this thing back on the road with as much speed as possible on a $250 budget. Now, last time I took this thing out, I was only able to top it off at 10 miles an hour, which I personally think is a little too slow for an adult to have fun with it. But considering it has rubber tires, a disc rear brake, suspension, and a metal frame, I think it makes a good platform for modifications similar to my Razor MX 650s, which both go 50 miles an hour, but those both run on a 72 volt brushless motor setup, which is obviously gonna cost a lot more than what we're doing to this thing. The main limiting factor of this setup is certainly gonna be the original battery, which he wants me to retain. This one is made by Radio Flyer, and it is lithium, but it's 36 volts, which is gonna limit the amount of RPMs we're able to get out of the motor. But it looks pretty sleek. I like how it fits back here. And it's also $500 from factory, so we might as well get some use out of this original one. Now, if this was my bike, I personally would like to get a 72 volt 30 amp hour battery and jam it in here, since there's a lot of space in the center of the chassis. But this is his build, and we're gonna do exactly what he requested. Hopefully we can get at least 20 miles an hour out of this thing. Here's everything that we're gonna be using for today's project. Now, if you followed my channel for a while, a lot of this stuff's gonna look very familiar to you. That's because I used a very similar kit on my blue MX 650 back when it was a 48 volt setup. This is a MY1020 Brushless Kit by Kunray, and it's rated for 1,000 watts, which is a lot less than what's on my bikes, but this is plenty for this quad. This Tesla Cyberquad is only rated for 500 watts, and it's using a 1016 brushed motor, so it's definitely going to be an upgrade. I'm really hoping that the bolt pattern on the motor bracket is the same or similar. Otherwise, we're going to have to do some modifications. So this kit comes with a 30 amp 1000 watt brushless controller, chain and sprocket set, which we're likely not going to be using for this setup, hardware and toolkit, a twist throttle with a built-in 3-speed switch, and front and reverse. User manual, a junction block for the phase wires and the power wires, a keyed ignition switch, and another 3-speed switch, which we're likely not going to be using. I'm not really sure if I'm going to be using this because he does not want me to drill into any of the factory panels, but we'll find out. And if you are interested in checking out any of the items that we're using for this project, I will have everything linked in the description below. All right, let's get started on the disassembly. It is certainly a lot different than what I'm used to with the MY1020s. I wasn't expecting there to be dual tensioners on here and this fat chain, along with this gear reduction housing with the huge front sprocket and tiny rear sprocket. I also wonder if this changes the rotation of the shaft, since these motors, I'm used to working on bikes with it mounted the other way. I wonder if that also reverses the direction. So I might have to wire the controller switch backwards for forward and reverse. We're gonna have to experiment some. Just using a 5mm Allen socket to remove the motor mount bolts from the bottom bracket. Here's how the motors look side by side. You can immediately tell that the Kunray motor casing is significantly larger than the original one. If we ignore this gear reduction assembly up front, and I don't think I can use this sprocket on this motor though, it's gonna be way too much load. So we're gonna have to experiment with the gearing some. One thing that I was concerned about was the motor mount bolt hole pattern is definitely much wider on the new motor versus the original one. So we're gonna have to definitely drill the swing arm, but we're gonna have to figure all that stuff out when we position this new motor on the swing arm exactly where we want it with a chain alignment. But before we spend too much time modifying the bike to fit this Kunray motor kit, I want to confirm that I can get this motor to spin counterclockwise at full speed. So I'm going to hook everything up temporarily and test the reverse function. I just made a temporary power supply cable to connect the battery to the controller so we can test this out. I have an inline 30 amp fuse in here, and then I have ring terminals on one side to connect to the junction block, and then ring terminals also on the other side to temporarily slip into the ports in the battery. Now this is temporary. I already have a CX50 battery connector for this thing. It's just not gonna be here for another week or so. So we are just using this for testing reasons. Please do not do this at home. Here's how everything hooks up together per Kunray instructions. Power source and ground hook up to red and black on the controller, and then everything connects together on this junction block that's provided with the kit. This is where all the big wires go, such as the phase wires. All brushless motors, doesn't matter if it's an RC motor or like a big QS motor, have 3 phase wires. They're usually green, yellow, and blue. Just match them up. And then there's a 5-pin Hall sensor connector coming from the motor, just connected to the matching connector on the controller. And then there are 3 separate connectors that hook up to this specific throttle, since there's 3 separate functions on this one. The first one's the obvious twist throttle, one is the speed switch, and the reverse switch. And each connector is already labeled from factory, so it should be pretty easy to figure that out. And there is a keyed ignition over here. These 4 connectors, or these 5 connectors, we're not gonna be using. 2 of them are for the brake lever switch. So if you have like a Razor MX650 and you hook these up to the factory brake levers, it'll cut power to the controller when you apply brakes, and then it just sends signal to a brake light. And then this one's just a charge port, but we're not going to be using this since the Tesla battery has its own charge port. And then one wire that I might be using is this indicator light, since the Tesla quads have these factory LED headlight and tail lamp set. So I might make it work with this. I'm gonna test this out if this puts out 12 volts. So let's turn this thing on, test it out. All right, standard speed. So as you see, it spins clockwise, not counterclockwise like it's supposed to. So if I go in reverse, it spins counterclockwise, but not as fast. You can hear it. And then even on a faster setting, slower setting, the reverse mode is fixed. So we're gonna have to figure something out as far as potentially swapping out the wiring to reverse the polarity to make it spin the other way. I'm gonna have to do a little bit more research. After reviewing some wiring diagrams and experimenting with a couple different combos, I was able to figure out how to reverse the polarity and the direction of this MY1020 motor. Starting with the phase wires, I left the green going to green, and then I switched yellow and blue. You'll see it's mismatched. And I tried turning the controller on and twisting the throttle. The motor looked like it was trying to go counterclockwise, but it was fighting itself and was making a bunch of whining noise inside. So I looked further into it and I saw someone online switch the yellow and green wire on the Hall sensor connectors on the motor side. So you see it's mismatched. So those are the only 2 wires that I switched. I just depinned it with a picking tool. And let's confirm. Forward, middle setting, much higher speed now going counterclockwise. And if I go in reverse, it goes clockwise. So that is how you reverse the direction of an MY1020 motor. And here's a simplified diagram showing what I did in case you want to pause the video. Here's the general idea of how I'm planning on mounting the motor. I'm thinking about drilling new holes on the motor mount bracket instead of modifying the plate on the swing arm, just to keep as much of the Tesla unmodified as possible in case we change the setup in the future. Before we start installing the controller and wiring up a bunch of components on the Cyberquad, I want to figure out where these 7 wire connectors hook up to. Unfortunately, none of them are labeled, and there's very limited information or wiring diagrams available for this bike online. It should be pretty simple to figure out with a process of elimination approach. There's very limited components on this bike. Like on the front, there is a brake handle, an LED light bar, a thumb throttle, a forward and reverse switch, and then on the back, you got the LED taillight, a mode switch, and an on-off switch. I'm just gonna start tracing each wire individually and start labeling them one by one. All right, I think I got everything figured out. The 2-pin connector with black and red going to the back is for the on-off switch. The 3-pin connector with black, white, and red going to the back is for the brake light. One is ground, one is power, one is a signal wire. The 2-pin connector going to the back with blue and red is for mode switching, high and low. And then the other 4 connectors going to the front. There are 2 connectors going to the front that are black, blue, and red. Just so we don't get them confused like I initially did, obviously. Thicker gauge wiring is for the brake, and the throttle is the thinner one. Or another way to look at it is the larger clip, the one with this tab right here, is for the throttle. And then the smaller clip with the tabs on the side is for the brake. Forward and reverse switch, this thing is a 2-pin connector with red and yellow. And then the LED headlight is a 2-pin connector with black and yellow. And to simplify things, I'm gonna start removing the parts that we're no longer gonna be using, such as this thumb throttle and this forward and reverse switch. I'm also gonna tuck away the connectors we're no longer gonna be utilizing, such as this speed selector and on-off switch, since the new thumb throttle that we're installing has the built-in forward and reverse switch and speed selector. What's pretty interesting about removing the factory thumb throttle is you don't just loosen the Allen bolt like you usually do on most e-bikes and whatnot. They actually have this tab on the inside that sticks out to keep it from, I guess, rotating. You can see that there's a scratch from factory installing it, so I'm not really sure why they did that. They want to make it an extra pain in the ass to remove this, so you don't try to modify it. So it turns out there's no need to cut the tab off. You just need to take the 3mm Allen bolt out all the way, and this metal ring actually separates from the whole housing. So you slide this housing off, pry this with a flathead and slide the ring off, and then you can just reassemble it. After taking a closer look at the bottom side of the switch panel, I've decided to keep this forward and reverse switch in place and just repurpose it as an on-off switch, since it essentially does the same exact thing. It's just 2 wires. One setting just breaks a circuit and the other one completes it, which is exactly the same thing an ignition switch does. You key it on, it completes the circuit. You key it off, it breaks it. So I think it looks a lot cleaner this way if I were to just keep this in place and install the same 2-pin style connector from the ignition switch. I was initially having an issue with the sticky throttle. I think the inside of the twist grip was making friction or dragging on the black anodized surface. So I sanded it smooth with some 240 grit and then some 400 grit, and now it stopped sticking. After doing some further research regarding MY1020 gearing, it appears to be more appropriate to install a larger sprocket than the factory one in combination with a 11-tooth T8F motor sprocket. The larger sprocket, this one is a 54-tooth. This will give it a lot more low-end torque and help it pick up speed a little bit quicker. Yes, the smaller stock sprocket can produce a higher top speed, but it will be very sluggish and slow to pick it up to get there. This will make it easier for it to accelerate from a stop. Careful not to lose this dowel key. This is what keeps the sprocket from rotating on the shaft. Make sure you put this back in when you reinstall the sprocket. There is also a locking screw that keeps it from sliding back and forth. Check out the size difference between the original sprocket and the new 54-tooth sprocket. And here's how we're looking so far. If I put a bolt through the back right mounting hole, it positions the motor so the front sprocket is perfectly aligned with the rear sprocket as far as chain alignment. So I'm going to use that as a baseline to mount the motor in place. And then I'm going to drill the motor mount bracket through the holes at the bottom of the swing arm to figure out the correct location for the other 3 mounting holes. And then we're going to fix the chain slack by taking out a couple links. I'm thinking maybe 4 or 5 links will do it, which will make the chain the perfect length, so we might not even have to use a tensioner at all. I'm going to be using this T8F chain that came with the Kunray Brushless Kit, which comes with a quick link that I can easily remove, shorten the chain, and reconnect it. And to shorten the chain, I'm using the chain detacher. I just got this one from Amazon. If you are interested in checking out any of the items that we are using for the Tesla project, I will have everything linked in the description below. So I'm glad that I got the chain to the right length before I drilled the holes, because now that I'm rotating it, it does seem like there's too much tension the way this is. So I am gonna have to move the motor back ever so slightly and re-drill all 4 holes to get this thing to line up correctly. Here's a closer look at how the motor ended up being mounted, top and bottom side. As far as alignment goes, it is perfectly lined up and there's just enough chain slack to not need a tensioner. No resistance. As of right now, I have everything for the controller hooked up except for the brake switch, brake light, and headlight. I'm temporarily connecting the terminals directly to the battery, of course with an inline 30 amp fuse, just for testing purposes. Quick reminder, this controller is hooked up, so it's reverse polarity since this motor is hooked up the other direction. I ended up just switching the yellow and green wires on the hall sensor connector, and I switched the blue and yellow wires. I just crisscrossed them on the phase wires. Green is still to green. Let's go see if this thing works. Okay, so it's on. Okay, so the on-off switch works. Reverse. Forward, mode 2, forward, mode 3. Yep, certainly seems like it's going to be faster than the 10 miles an hour it originally was. I finally got the last piece that I needed in order to take it out and safely do a top speed run, and that is the CX50 battery connector. It's very specific. I was not able to find it anywhere in stock in the US, so this one had to come from China. Now that we have the CX connector wired to the controller with an inline fuse, this is a 30 amp, I'm going to slip this into the battery port area and secure it in place with this mount. It looks like it's 3D printed. This came with the CX connector. Can't say I'm too impressed about the quality of this adapter, but it is literally the only option that we have. And as long as it works and it properly secures the battery connection in place, I'm gonna be totally fine with it. And this is what it looks like on the back side. So the battery just slides in there and connects to those two pins. All the wiring's tucked, got plenty of clearance under the seat. Charge. And to measure top speed, I just mounted on a Cyc Plus GPS based speedometer, which is what I use to measure speed on all of my bikes.
All right, well, this thing definitely goes over 22 miles an hour. I'm curious to see how fast it goes in reverse. Holy shit. This thing is super sketch going backwards. All right, top speed was 23.3 miles an hour. All right, guys, we did it. We got this Tesla Cyberquad that was previously disabled back on the road with double the speed for less than $300 using the original lithium battery pack. One thing I did notice while riding it is we sacrificed a little bit of low-end torque for a trade-off of higher top speed, and that's simply because of the aggressive gearing here. One thing I could do to increase the lower end torque is to step down this 11-tooth front sprocket to a 10-tooth, which may give up like 2 miles an hour off the top speed, but it will add a little bit of low-end torque. Or the other option, which is my opinion the better option, is to replace this 36-volt battery with a much larger 60-volt lithium battery pack to mount in the center of the frame, which will lower the center of gravity and increase the overall capacity and range. Combine that with a higher output brushless controller to overvolt this current motor, which will give this thing a lot more torque and a higher top speed overall. I ended up switching out the sprocket on the motor to a 10-tooth T8F and sliding the motor slightly forward to maintain minimal slack on the chain. I was hesitant of doing this at first because I thought the chain was going to make contact with the nut on the sprocket, but it barely clears it and it doesn't walk off the sprocket or anything. This allowed me to keep a top speed of 22 miles an hour while regaining some of the low-end torque back. So if you are concerned about that, I highly suggest using a 10-tooth sprocket. All right, guys, if you enjoyed today's video or found it helpful in any way, do me a favor and hit that like button. And if you like this kind of content and want to keep up with some of my projects, some of my rides, consider subscribing to this channel. But this is going to be it for today. Thank you for watching.